Hi, good morning. This is Purush Assistant Professor, Department of ECE, JJ College of Engineering and Technology. Today we are going to discuss about wireless sensor networks and its applications. So these are all the contents we are going to discuss in this topic. Introduction, the architecture of wireless sensor networks and wireless sensor network node, and architecture of sensor node of course, then wireless sensor network versus mobile ad hoc networks, and characteristics of wireless sensor networks, and applications, design challenges, advantages, disadvantages, future and references are there. And this is the introduction part of wireless sensor network. The wireless sensor network is a wireless network which consists of spatially distributed autonomous devices using sensors to cooperatively monitor physical or environmental conditions such as temperature and vibrations, pressure, etc. So here it is a collection of sensing devices that can communicate wirelessly. So here even though wireless sensor networks has limited resources in memory, in computational power, bandwidth and energy, with small physical size, it can be embedded in a physical environment. Self-organizing multi-hop ad hoc networks is also possible here. So this is the architecture for our clarification. So here this one is said to be sensor nodes. Here the sensor nodes are connected together with gate sensor node for consumer usability. This is architecture for wireless sensor network. Of course, a special addressing requirement is needed here, that is local unique address, then data centric. For example, here each node has a unique number. So attribute based naming architecture is also possible here. And data is named by one or more attributes. For example, each node is distinguished by an attribute. See, the wireless sensor networks has sensor. We know the definition of sensor. It's a transducer like. So it converts physical phenomenon like heat, light, motion, vibration, etc. into electrical signals. Sensor node, it is a basic unit in sensor network. It contains onboard sensors, processors, etc. Sensor network, it is a network. It consists of large number of sensor nodes here. The nodes deployed either inside or very close to the sensed phenomenon. So this is the architecture of sensor node. Here the microcontroller which controls all part of the wireless sensor network. The power source is also available here. The external memory for the database. The transceiver, you know the meaning of transceiver of course. The transceiver is nothing but the combination of transmitter and receiver. So, analog to digital, I mean ADC is also there for sensors. The data aggregation in wireless sensor network, it solves implosion and overlap problem also. It is energy efficient too. This is the differences for your clarification. Wireless sensor network versus mobile ad hoc networks. The similarity, let us consider the similarity of wireless sensor network with mobile ad hoc networks. The similarity here is wireless, but here it is multi-hop networking. The security here is symmetric key cryptography and here public key cryptography. The routing here is the routing here supports a specialized traffic pattern, but here it supports any node per some source routing, etc. The resource here is tighter resources. I mean it's for power, processor speed, bandwidth, etc. This is not as like wireless sensor networks. These are all the characteristics of WSN, I mean wireless sensor networks. The power consumption constraints for nodes using battery energies are harvesting here. Then ability to cope with node failures, of course. Mobility of nodes, the nodes will be transferred from this area to that area, that is mobility of nodes will be there. Then heterogeneity of nodes, I mean the computational and frequency accessibility processability differ while comparing with homogeneity. Then scalability to large scale, and ability to withstand harsh environmental conditions, and easy to use, of course, cross-layer design. The factors influencing wireless sensor network design, these are all the factors: the fault tolerance, the scalability, the production cost, hardware constraints, environment, and transmission media, power consumption also plays an influencing factor in WSN design. So these are the applications of wireless sensor networks. It can be used in military applications, environmental application, health monitoring applications also, then home applications, we may use it in our home applications also, and automotive applications, other commercial applications is also possible here. There is some advantages out there. It avoids a lot of wiring. So if we use wiring, no, it will take a very long time, but here we can avoid a lot of wiring also. It can accommodate a new device at any time. We can accommodate any new device at any time here. It's flexible to go through physical partitions. It can access through a centralized monitor. By using a centralized monitor, we can access a wireless sensor network. So of course some disadvantages are there. Low speed compared to wired networks. So whatever may be the networks, the comparison between the wireless and wired networks is major here. The low speed compared to wired network. Less secure because hackers' laptop can act as an access point here. Then still costly at large. It does not make sense quantities in building easier. It does not reduce cost for installations of sensors. Some design challenges are there here. Heterogeneity, then distributed processing, low bandwidth communication. Heterogeneity, of course, we discussed earlier. Distributed processing, the algorithm need to be centralized as the processing is carried out at different nodes. If you use different nodes, no, the distributed processing will differ. Low bandwidth communication, the data should be transferred efficiently between the sensors. This is the continuation of it. Large scale coordination should be there. I mean, the sensors need to coordinate with each other to produce required results. Utilization of sensors utilization is very important here. The sensors should be utilized in a way that produce the maximum performance and less energy. Energy should be very less. The energy consumption should be very less. Real-time computation. The computation should be done as quick as new data is always being generated. This is some operational challenges of wireless sensor networks. Energy efficiency is there, unlimited storage and computation, low bandwidth and high error rate. And errors are common here. I mean, wireless communication error, noisy measurement, node failure are expected here. The experiments are time and space intensive. For our reference, this is a future application. We can use it for wireless sensor networks. The sensors controlling application and electrical devices in the home itself. Better lighting and heating in the office environment. The Pentagon, this is the Pentagon shaped building. The Pentagon building has used sensors very extensively. So I would like to conclude. So wireless sensor networks possible today due to technology. Technologies have been changed a lot. So it is possible today due to technological advancement in the wireless. I mean in various domains. Envisioned to become essential part of our day-to-day lives. Design constraints need to satisfy for realization of sensor networks, and tremendous research efforts have been made in different layers of wireless sensor networks. I mean the layers like physical layer, data link layer, network layer, transport layer, sessions layer, application presentation layer are there. No, so there are a lot of research efforts is being taken in the layers. So thank you.